But now researchers may have found some answers thanks to a serendipitous discovery from an unlikely source. Let's take a look at how scientists finally figured out if it actually rains diamonds on Neptune. The idea that Neptune rains diamonds came about in 1984 when scientists studying meteorite samples found tiny inclusions inside. These are called nanodiamonds, and they're extremely small, less than 5 nanometers across. But scientists determined that they were pure crystallized carbon, the same stuff that diamonds are made of. So where did they come from? They realized the only place in the universe that could have created them was the atmosphere of Neptune. That's because the pressure and temperature deep in Neptune's atmosphere are just right to cause carbon atoms to bond together and form diamonds. It makes sense that this happens on Neptune and its icy sibling Uranus because they both have a lot of carbon in their atmospheres, much more than Earth does. Scientists think that when these planets formed, they accreted or gathered up a lot of methane gas, which is made of 3 hydrogen and 1 carbon atom. Over time, the swings in pressure and temperature as the planets moved through the early stages of their formation caused the methane to break down into its basic components, which then condensed into clouds of hydrogen, sulfide methane, and yes, carbon. Eventually, the carbon reached a critical density and started raining down from the planet's atmosphere. But since no spacecraft had visited Neptune, scientists couldn't confirm this hypothesis until now. A new paper published in the journal Nature on August 3, 2023, describes a serendipitous discovery from NASA's Curiosity rover that provides the first evidence that Neptune rains diamonds bigger than grizzly bears. Yeah, you heard me right, big diamonds. So how exactly did a Mars rover provide the first confirmation of what happens on an ice giant hundreds of millions of miles away? Well, it all has to do with a Martian dust storm. In late 2021, Curiosity was exploring an area of Mars called the Jezero crater when it encountered a dust storm. It wasn't the first dust storm Curiosity had seen on the red planet, but this one was unusual because it lasted for months. And during the storm, Curiosity detected an increase in the amount of an element called argon in the air around it. Argon is usually pretty unreactive, but when it gets superheated, it can combine with other elements to create ions. These charged particles can then react with other molecules in the atmosphere to form aerosols, tiny solid or liquid particles suspended in the air. When Curiosity's instruments detected those aerosols, researchers realized they were coming from the dust storm and not from the rover itself, so they were able to determine their size, shape, and chemical composition. And here's the thing, the team found that the aerosols were mostly made of iron oxide, magnesium, and calcium, the same elements that make up olivine and pyroxene, 2 minerals that form deep in the mantles of rocky planets like Mars and Earth. Where did these minerals come from? Researchers think they were carried up from the deep interior of Mars by a plume of hot magma. Basically, Mars experienced a giant burp, and while that might sound surprising, it actually makes sense that Mars would occasionally release some of its deep interior gases and minerals to the surface. After all, Mars doesn't have a core like Earth that separates its mantle and crust. Its core is molten, and it's only about 1,200 miles across. So there isn't much distance for material to travel before it reaches the surface. So the fact that Mars occasionally releases material from its deep interior is not particularly surprising. What is surprising is how much of it was released during that one dust storm. But there was something else in the aerosols that really surprised them. Remember that increase in argon that kicked off this whole investigation? Well, they also saw an increase in another element, nitrogen. And that was weird, because Curiosity had previously detected nitrogen all around the Martian surface. So why would a dust storm kicking up rocks from the deep interior suddenly increase the amount of nitrogen in the air? It didn't make sense until researchers considered the possibility that the nitrogen wasn't coming from the dust storm. Instead, it might have been coming from something else entirely, like space. You see, nitrogen is the most abundant element in our planet's atmosphere. But that wasn't always the case. Early in Earth's history, it existed in the atmosphere as molecular nitrogen, N2, which is incredibly stable and unreactive. Molecular nitrogen is hard to break apart because it requires a lot of energy to overcome the strong triple bond between the two atoms. So, in Earth's early atmosphere, most of the nitrogen was unusable to life. That is, until lightning struck, creating reactive nitrogen that could fuel life. Since then, bacteria have cycled various forms of nitrogen into the atmosphere, making it habitable for life as we know it. Curiosity detected lots of nitrogen on Mars, too, though in a different form. Martian nitrogen exists as nitric oxide, which is very reactive and quickly breaks down when exposed to UV radiation from the sun. This means that any free nitrogen on the surface should be constantly replenished from below the surface or from outer space. But Mars doesn't have an active core like Earth, so it isn't producing any nitrogen. Plus, Mars' thin atmosphere and lack of a global magnetic field mean that it's not getting much from the sun either. So where is all the nitrogen on Mars coming from? The researchers think it's falling from the sky in the form of diamonds. When they analyzed the aerosols produced during the dust storm, they found that the iron-rich mineral grains contained tiny pockets of nitrogen, and even more surprisingly, they also contained small amounts of hydrogen and helium. Together, this points to a fascinating conclusion. The minerals themselves are actually diamond inclusions that formed along with the diamond crystal lattice. And the fact that they are full of nitrogen suggests that diamonds are raining down on Mars from space. Of course, this isn't the first time researchers have speculated that diamonds rain on Mars. Back in 2017, researchers studying meteorites believed that many of the nanodiamonds they found on Earth might actually have originated on Mars. So it seems likely that diamonds do rain on other planets, but the evidence for Neptune was still lacking. Until now, the team hopes that their new findings will help focus future studies on Neptune, and that one day we'll get confirmation of what's been suspected for decades. These discoveries show that all kinds of crazy things are happening in our solar system, and it's important to keep studying it. And with your support, we can keep bringing you up to date on all the latest discoveries. When we started this channel, we had no idea that it would take off the way that it did. But now thousands of eyeballs are on us every week, and we've had to raise our budget to meet that demand. Thankfully, you answered our call for help, helping us raise over $100,000 to improve our video quality and hire more people to help us. But we need your help again. We don't want to lose momentum, but we also don't want to sacrifice quality. We're aiming for $250,000, and we're already halfway there. If you'd like to help us reach our goal, click the Join button and become a patron today. As a thank you, we'll add your name to the end of our credits. Now let's move on to our next story about strange weather on other worlds. Imagine you're standing on the dwarf planet Pluto taking in the scenery, maybe having a picnic lunch or something, and all of a sudden, you feel the ground shake beneath your feet. You look up and see huge hailstones hurtling toward you. Hail on Pluto is 6 times the size of grizzly bears. Yes, that's right. In a new paper published in the journal Geophysical Research Letters on July 26, 2023, researchers reported discovering massive hailstones on Pluto. They found evidence of these gigantic balls of ice on Pluto's largest moon, Charon, as well as on the dwarf planet Makemake. Now, you might be wondering, how do you discover hailstones on a dwarf planet 4 billion miles away without actually going there? And to that, I say fair question. As it happens, we took a little trip to Pluto. In 2015, NASA's New Horizons spacecraft flew past Pluto and captured incredible images of the dwarf planet and its moons. It even captured an image of a mysterious, bright, heart-shaped region on Pluto that became known as the Tombaugh region after the spacecraft's mission. Scientist Alan Stern, who leads the New Horizons mission, says the heart region was likely chosen for the close-up flyby because it appeared to have geological features that were younger than the rest of the planet, meaning that it might tell us more about recent activity on the planet. Among those geological features were vast plains that looked suspiciously like impact craters. But upon closer inspection, scientists noticed that these plains weren't smooth. but instead were full of jumbled blocks of ice. And that meant that these features weren't caused by an impact, but instead by giant hailstones. But the real question is, how could such large hailstones exist so far from the sun? Pluto receives almost no sunlight, so the surface of Pluto is extremely cold, around negative 375 degrees Fahrenheit or negative 225 degrees Celsius. Under those conditions, water exists as ice. And hail forms when water ice condenses high in the atmosphere and then falls to the surface. It turns out that on Pluto, this process happens on a gigantic scale. Researchers estimate that the hailstones fall 3 miles per hour and weigh over 1 million pounds each. Eventually, they smash into the surface and leave behind the jumbled piles of ice that were captured by New Horizons. It's not clear whether these hailstones ever melt once they hit the surface, but what is clear is that Pluto has an active interior. That's probably due to the gravitational tugging of its moon, Charon. Just like Earth's moon causes tides on our planet, Charon's gravity pulls on Pluto, creating heat that keeps its interior molten. And it's not just Pluto that experiences gigantic hailstones. Scientists have spotted similar ice fields on Makemake, another icy world in the Kuiper Belt. Researchers are excited about this discovery because it suggests that hailstorms are a common feature of icy bodies throughout the solar system. And by studying these phenomena, scientists can learn more about the makeup and habitability of worlds beyond Earth. So next time you feel a raindrop on your face, remember that you might be experiencing something similar to hailstones on Pluto or even diamond rain on Neptune. And I hope you enjoyed learning about some of the amazing places in our solar system. Thanks for watching this SCI Show Space video.